A big warm welcome to Martin from Amazon. He's here to talk to us about browser-based applications and kind of how they can interact with services. It's going to be really interesting, I think. A warm applause for Martin.
Okay, thank you very much, Leo. Right, so my name is Martin Elwin. I head up the Solutions Architect team for Amazon here in the Nordics. We're just getting our office started here in Stockholm to work with the customers all over the Nordics, so it's really fun to be here today. So I'm going to talk a little bit about NoSRV Architecture. Who has heard the term NoSRV Architecture before? Raise of hands. I actually made it up for this talk, so I'm not surprised that not that many raised their hands. But the idea is not that strange, really. And it's not specific to AWS, but I want to talk and share a little bit about what we have done in this area. So as with many other things at this conference, we're going to start with JavaScript. And today, as you know, JavaScript is everywhere. We have it in the browser, we have it on the back end. I think my first exposure to JavaScript was on the back end, developing server-side logic for Netscape enterprise servers, something like 15 years ago. And then, of course, it started shifting more towards being used in the browser. And now we're back on the server with Node.js and back to the browser again with like single-page applications and things like that. And of course, the SDKs that we have for Amazon services, you use the SDKs to interact with APIs from different languages, and we have them for Java and .NET and Python and Ruby and PHP, etc. But of course, since JavaScript is so prevalent nowadays, we also wanted to support JavaScript. So about a year ago, we released the JavaScript SDK for Node.js. And it's a full-fledged SDK that you can use to interact with all the different services. And this has received really good, was received really well by the Node.js community. A lot of people have developed plugins and additional libraries utilizing the Node.js library. And the Node.js library, of course, you still use it in a very traditional way. You have your Node.js server that runs on your backend server machines. It could be a physical server, or maybe in the cloud even, if you use Amazon services, for instance. And you're all familiar with this architecture. You have your client, it might be a mobile client or a browser client. It calls your backend server, where you have some logic, maybe to generate pages, or just an API layer that then communicates with the backend data services. It could be some database or some storage service, or, well, what have you. But we saw that some people in the sort of JavaScript community, and we ourselves as well, saw that if you now have this possibility of writing JavaScript to interact with the services from the application layer, why can't you do it from the browser? What would that mean? Directly interacting with the data services from the browser and implementing all your logic there. So doing that, we're looking at a two-tier web application instead of a three-tier. A less sexy name for two-tier web application is, of course, client server, but we don't want to talk about that because it has too many bad connotations. But that's basically where we are. Of course, a web-based client server is not necessarily the same as the old legacy client server, but it looks similar. So with a two-tier application architecture, we have the logic implemented purely in JavaScript, in this case, running in the browser, communicating with the data services on the back end. And there are a number of benefits of doing it like this. To start with, fewer moving parts, so less complexity in your architecture. You don't need to maintain some kind of server application to run on services, and you deploy it and manage it and implement it. So all of the logic is in the browser. So if you develop something like a single page application, you might already have a lot of logic in the browser, so why not have all the logic in the browser? Do you really need that additional layer on the back end and managing that? Could be a good way to just prototype functionality instead of implementing something spread over multiple layers. Just implement it in your JavaScript code in the browser and then use the data services directly. And since in this case we're talking about having static applications, really, the files we deliver to the browser, they're all static, so they don't even need a proper web server to host the application. You can just put them in something like S3, which delivers files to your users without you having to do anything special. So S3 is the simple storage server, which is one of the storage services that Amazon provides. But you could host it on something else as well, of course. And this might not be suitable for all kinds of applications, but there are a few ones that maybe stand out. Forum software, something where you have a GUI that just retrieves a set of pieces of information from the backend, say posts or comments or blogs or pictures or whatever it might be. So anything basically where you have a JavaScript implementation of the logic, something like a Firefox or Chrome extension is another example. And to do this, we took the Node.js SDK and sort of stripped away the things that are not really relevant for a browser environment and created the browser JavaScript SDK. And this was released just a few months ago, and it's in a developer preview, so it's not really fully there yet, we feel, but we're working on it and improving it. It is open source licensed and available on GitHub, so we of course welcome any kind of issues, pull requests or what have you if you look at this. And to get the SDK and use it in your application, you can either use our CDN or just host it yourself, of course, as any other JavaScript library. So today we support 5 different services, and these again are the data service. So the pattern is not specific to AWS, but this is what we have been trying to do and figure out how it would work with our services. You could use the same kind of patterns in other situations or with other providers. So the 5 services we support now are the ones that we think are most relevant to have in a situation where you have a 2-tier web application. So the first one is S3, as I mentioned, the simple storage service. And it's a high-scale object or file storage for online storage of things you want to deliver to users. It currently has trillions of objects and delivers regularly over 1.5 million requests per second, so it's a pretty large-scale service. DynamoDB is a key value store. So you use it as a normal NoSQL database. You could store information about, again, blog posts or comments or what have you in there. SQS is a queue service. SNS is a multi-subscriber queue or topic service. And STS is the secure token service, what we use to authenticate to the API. And I'll get into that in a bit. So the SDK is supported in all modern browsers, which might cover most common needs or not, depending on what environment you run in, of course. So let's look at a web application. We've developed a small example just to show what kind of application could be done using this pattern. And it's a simple blog application. So it supports public users that just read the information, and you can log in as an administrator to post new blog posts. It uses DynamoDB to store all the text and data for the blog posts, and it uses S3 to store the pictures that you might want to upload as part of the blog post. So let's see if I can see. So it's not very fancy looking, right? It's an example application. So it is a single page application. It has a single HTML file. It has some JavaScript, some CSS just for basic styling. And what you can do is to log in. And this is integrated with a Facebook authentication mechanism that they provide for Facebook applications. We also support Google and the login by Amazon authentication method. So this is a federated way of authenticating your users without having to sit on identity store yourself or managing passwords and things like that. So if I log in, I can't see anything, but I'm taking a guess here. So So now I'm logged in, and the rules are set up so that only my Facebook user is allowed to act in the role as an administrator. But this is all done now on the server side, on the client side. I've established the identity using the Facebook authentication mechanism, and I can use those credentials that I get to interact with the backend services directly. So I can create a post, and we just have a small, simple markdown editor. And we modified the file picture attachment to support upload. So what this does is just uploads a file from the local storage directly onto S3, and only I, as an authenticated user, can do that. And it has a real-time preview, this editor, so you can see directly. And I publish it, and it gets stored in DynamoDB directly. So it's an example of a dynamic application storing data securely by authenticating the user without actually having to have any backend logic that you control yourself or having to deploy. This is also available on GitHub for anyone interested in seeing how it works. So, quickly moving on. So what does that mean? So the example, well, there are a few things that you need to keep in mind if you want to build an application like this. And they are primarily related to security. The first one is cross-origin resource sharing, or CORS. Normally, the security model in the browser prevents JavaScript from making calls to other services or other domains than what the JavaScript was loaded from. So if you want to interact with a third-party service like S3 or DynamoDB or something else, you need to take a CORS, or cross-origin resource sharing, into consideration. So CORS allows the browser to actually make these calls, and it's the browser that makes a pre-flight call, an HTTP options request to the third-party service, which needs to respond in a special way to say that, yes, we do allow call to this service. And looking at S3, there is a CORS configuration that you can set up for your bucket where you store your files to say that, yes, we do allow these API calls from JavaScript for certain domains. Other services like DynamoDB and SQS, they allow calls from any domain, so you don't need to configure that yourself. But S3, you can have custom host names there, so that's why we have a custom CORS editor as well. The next thing is, how do you get the credentials onto the device? Of course, when you use an API to communicate with the service, you need to authenticate yourself so you know who it is actually performing the operations. And as I mentioned, we don't do this by hard coding credentials in the web application. That would be bad, because then anyone could look at the code and use them to communicate with the backend. Instead, we use the web identity federation in this case. So we authenticate with some provider like Facebook or Google or even Amazon's version of this, and use that as the credentials towards the APIs. And just quickly what this looks like, if you're familiar with the AWS SDK, you specify a credentials object, but instead of putting in your secret key, access key and secret key, you say that you want to use the Facebook identity provider or Google or what have you. And you just get the token to provide from the normal Facebook authentication library. The third part you need to take into consideration is fine-grained policy. Since we don't have an application tier with logic to determine what the user can do and not do, you need to define what the user can and can't do in the actual data store. So we're back to actually controlling access to different pieces of data by setting policies in the data store. In this example on AWS, you use the policy language to say that, well, for the admin user, we only allow put item and delete item to a specific table in DynamoDB, and put the object and control the ACL for the object in S3. Since we want to make the object public, we also need to modify the ACL. Or similar mechanism with whatever service you might be using, but this is something to keep in mind. So you can do this too. it's not an all or nothing thing. Even if you're not developing a two-tier application, you can still benefit from doing these things to not put load on your own servers by using these managed data service directly. And this is not an official thing, but maybe it could be called a 2.5 tier application, where you have your normal architecture, but for certain actions, you go directly to the data services. As an example of this, Narrative, they were kickstarted using the name Memoto, I think, a year ago or so. They create this life logger device. It's a small thing that you clip to your shirt, and it takes a picture every 30 seconds. And then when you connect it to your computer, it can upload all these pictures. So they use the AWS services, instead of going through their own applications running on EC2, for instance, like a virtual machine, they go directly to S3. And what happened here, you can see that nothing was processed in the middle of the night during a certain day, but the uploads actually went to S3 since they use this direct connection instead of going through their services. And once they fixed the problem in their application, that just picked up and started processing the pictures that were uploaded. So, we love open source. We're on GitHub. If you use this or have any ideas or anything, please let us know. Pull requests, issues, really good. And code more. Thank you.